Hello, so question is saying this 0.27 gram of long chain fatty acid was dissolved in 100 centimeter cube of hexane. 10 ml of this solution was added dropwise to the surface of water in a round watch glass, right? So hexane evaporates and after this the monolayer is formed. The distance from the edge to the center of the watch glass is 10 centimeter. Now we have to find out the height of the monolayer that is formed, right? So we have given the density of the fatty acid that is 0.9 gram per centimeter cube, right? So for this, the value of, you have to use the value of pi is equal to 3, right? So for this, let's try to solve this question and find out the what is the height of this monolayer, right? So what is the height of this monolayer, right? So we have this round watch glass, right? So this is our round watch glass, right? So for this, the radius is you can see here the radius is 10 centimeter cube, right? No 10, yes, 10 centimeter, right? So for this, the radius is equals to 10 centimeter. This is our 10 centimeter radius, right? Let's say this is our R, right? Now you can find out the area of this watch glass, right? So for finding out the area, you have the formula that is area of the watch glass that is equal to pi r square, right? So the area of the watch glass, right? So you can easily write down the area of watch glass. Area of watch glass comes out to be here, that is pi r square, right? So you use the value of pi is equal to 3, right? So that is 3 into, what is the value of r? R value is 10 centimeter, right? So the value of r is 10 centimeter and it's square, right? So its value comes out to be 300 centimeter square, right? So this is the area of the watch glass, right? So now we have to find out the height of the monolayer formed, right? So before this, we know that 0.27 gram of long chain fatty acid was dissolved in 100 centimeter of hexane, right? So what do you mean by this? This means that, let's say, this means that the 100 ml, right? So in 100 ml of hexane, 100 ml of hexane contains 0.27 gram of long chain fatty acid, right? So now by just unitary method, you can find out the how many grams of fatty acid are present in 110 ml, right? So by just unitary method, you can easily solve it, right? So in 1 ml of hexane, right? So it's 1 ml of hexane contains is equals to 0.27, right? So that is 0.27, right? So this is 0.27 divided by 100 gram, right? So this is the amount of acid present in 1 ml of hexane, right? So but we have to find in 10 ml, so you can easily write down that is 10 ml of hexane, 10 ml of hexane, right? So this is 10 ml of hexane contains 0.27, right? So that is 0.27 divided by 100 multiplied by 10, right? So if you just solve it, so you will find that comes out to be 0.027 gram, right? So this is the amount of acid, long chain fatty acid, that is present in 10 ml of the hexane, right? So now we have used, right? So we have given a density of the fatty acid that is 0.9 gram per centimeter cube, right? So from here we can easily find out the volume, right? So we know that the fatty acid, right? So density of the fatty acid will be, density of the fatty acid will be, you can see this is density of fatty acid, and this formula is mass by volume, right? So formula is mass by volume, right? So from here you can easily calculate the volume, right? So from here you can easily calculate the volume, that comes out to be mass by density, right? So mass by density, and the value comes out to be 0.027 gram divided by, what is the density? The density is 0.9 gram, right? So that's 0.9 gram per centimeter cube, right? So 0.9 gram per centimeter cube, right? So from here you can easily see this, the from gram to gram cancel, right? And you can see here this comes out to be, volume comes out to be, you can see here after solving, the volume comes out to be 0.03 centimeter cube, right? So 0.03 centimeter cube, this is the volume, right? So this is the volume of the, you can say this, of this, right? So overall total system, right? So now you can see here we have to find out the height of the monolayer, right? So, and we know that the formula for volume, right? So formula for volume is pi r square h, right? So the formula for this it is pi r square h, right? So now we have to find out the value of h, right? So from this you can easily find out the height of the monolayer, right? So this is h, right? So this is actually height of the monolayer, and it becomes pi r square divided by volume, right? So this divided by volume, right? So now you can see the volume the area of the both glass we already find it, right? So that is 300 centimeter square, right? So that is 300 centimeter square, right? And the volume we have find it, that is 0.03 centimeter cube, right? So 0.03 centimeter cube, right? So this is the volume, right? So now we have to find out the, you can see here, we have to find out the, yes, we have to find out height of the monolayer, right? So we have to find out the height of the monolayer, right? So now you can see here the value, yes, I have made a mistake here, right? So I have made a mistake, you can see here. So we have to just volume here, because when pi r square goes this side, so it becomes in down, right? So that means mistakes here, so you can correct it, right? So the value here, you can see here, the volume comes upside and the area comes downside, right? So this now this is correct, right? So because this pi r square this side, so this comes down, right? So now you can see here, this becomes 0.03 centimeter cube, right? So 0.03 centimeter cube, and this becomes 300, right? So this is the area, centimeter square, right? So now the unit comes in centimeter, right? So this is the one method to just check it, right? So you can see here, just after solving you can easily calculate it, right? So the value comes out to be here 0.0001 centimeter, right? So 0.001 centimeter, right? So if you further solve it, right? So but in the question we have asked the answer in meter, right? So we have asked the answer in meter, right? So for this you can easily solve it, right? So you can easily solve it. So the value comes out to be height of the monolayer, right? So I can write here the height of the monolayer will be equals to, if I convert into meter, right? So it becomes into 0.000001, right? So this is the in meter, right? So, or if you want to write in scientific notation, that comes out to be the height of the monolayer comes out to be 10 to power minus 6 meter, right? So 10 to power minus 6 meter, right? So this is the height of the monolayer, right? So now let's check our option, right? So in our option you can see here, in the option A, that is to 10 to power minus 6 meter, 10 to power minus 8 meter, 10 to power minus 2 meter, 10 to power minus 4 meter, right? So you can easily choose the option, that option A will be the correct answer, right? 10 to power minus 6 meter, right? Option B, C and D will be the wrong answer, right? So hope this answered your question. So thank you.
Hello. So question says that 100 ml of water sample contains 0.81 gram of calcium bicarbonate and 0.73 gram of magnesium bicarbonate, right? So the hardness of this water sample expressed in terms of equivalent of calcium carbonate is 10 to power x parts per million, that is ppm, right? So we have to calculate the what is the numerical value of x, right? So here again the molar mass of calcium bicarbonate is 162 gram per mole, and magnesium bicarbonate is 146 gram per mole, right? So here the option. So let's try to solve this question. In the question it is said that 100 ml of water, right? So it is said that 100 ml of water, right? So if I write here 100 ml of water, right? 100 ml of water contains 0.81 gram of calcium bicarbonate, right? So I can write here as 0.81, right? So it is 0.81 gram. So it is 0.81 gram of calcium bicarbonate, right? So it is like this, calcium bicarbonate, right? So HCO3, HCO3 twice, right? Plus 0.73, right? So and 0.73 gram of magnesium bicarbonate, right? So it is magnesium bicarbonate, right? So HCO3 twice, right? So this is the, you can say that bicarbonates which is present in 100 ml of water, right? So we have to calculate the hardness of water, right? So in terms of equivalent of calcium carbonate, right? So I can write here as the number equivalent, or you can say the gram equivalent of calcium carbonate. The gram equivalent of calcium carbonate is equals to, the gram equivalent of calcium carbonate is equals to the gram equivalent of, the gram equivalent of, you can say that calcium bicarbonate, right? So it is equals to calcium bicarbonate. So it is HCO3, right? So it is HCO3 twice plus the gram equivalent of magnesium bicarbonate, right? So magnesium bicarbonate, right? So this is the equivalent formula, right? So I can write here as the hardness which is expected in gram equivalent of calcium carbonate is due to this the gram equivalent of calcium bicarbonate and gram equivalent of magnesium bicarbonate, right? So let's move further. So now we will see this the gram equivalent of calcium carbonate, right? So here I can write as how to find out the gram equivalent, right? So for finding out the gram equivalent, we know that the given mass, right? So what is the value of, you can say the given mass is here 0.81, right? So for this calcium carbonate, right? So I can write here as given mass is 0.81 divided by equivalent weight, right? So what is the value of equivalent weight? Equivalent weight is molar mass divided by valency factor, right? So for this the valency factor is 2, right? So I can write here as what is the molar mass, right? So molar mass is given like here. So it is 162, right? So I can write here 162 divided by 2, right? So it becomes 2, right? And plus it becomes 0.73, right? So it becomes 0.73 divided by 146, right? So divided by 146 divided by 2, that means that comes out to 2, right? So this is equal to number equivalent, or you can consider gram equivalent of this is equals to gram equivalent of calcium carbonate, right? So gram equivalent of calcium carbonate, right? So now this is equals to this is also equals to gram equivalent, right? So I want to find out the weight gram, right? So I can write here W. We don't know the how many amounts of are there of calcium carbonate, right? So I can write here W divided by molecular mass of this calcium carbonate is 100 gram per mole. And what is the value of equivalent with the valence factor, that is divided by 2, so it comes out to be 2, right? So it becomes, right? So if I take the common 2 and 2, right, from here, so I will get 2 is equals to 2 multiplied by 0.81 divided by 162 plus, and it is here 0.73 divided by 146, right? So here 2 to cancel out, right? So here I can write as easily the W is equals to, right? So or I can write here is W divided by 100 is equals to, right? So it becomes you can say that it becomes 1 divided by 200, right? So 1 divided by 200 plus, and it is also equals to 1 divided by 200, right? So it is also equals to 1 divided by 200, right? So now further solving it, I will get like this. So let's try to solve it. I will get W is equals to 2 divided by 200, right? And this is also 100, right? So I can say this, it becomes 100, right? So I can say this W is equals to 1 gram, right? So W is equals to 1 gram. So this is the weight, right? So this is the weight, right? So now you can say that this is the weight 1 gram of calcium carbonate in 100 ml, right? So this is the weight 1, or you can say this is in 100 ml, right? 100 ml water, 100 ml water, right? So if I want to find out the how many moles of calcium carbonate present in the 100 ml of water, so it is the given mass divided by molar mass. So I can write here as given mass divided by mole mass, it comes out to be 0.01 moles of calcium carbonate are present in 100 ml of water, right? So are present in 100 ml of water, right? So this is the right, this is the moles of calcium carbonate, right? So but we have to ask, we have asked in the question that the find out the grams equivalent in terms of calcium carbonate, right? So you have to find out the grams equivalent, right? So you have to find out the equivalent of calcium carbonate, that is equals to hardness, right? So that is equals to hardness. So let's try to solve it. We know that 1 ppm, right? So 1 ppm, let's convert in into ppm. 1 ppm is equals to 10 to power my, you can say that, or you can say that microgram per liter, right? So microgram per ml, not liter, microgram per ml, or you can say this 10 to power minus 6 gram per ml, right? So this is the equal to 1 ppm, right? So this is equals to 1 ppm, right? So if I want to convert for zero point 0.1 moles, right? Or you can say if I want to convert 1 gram of calcium carbonate into ppm, right? So it comes out to be, I can write here as, I can write here as 10 to power minus 6 gram, 10 to power minus 6 gram per ml contains is equals to 1 ppm, right? So I can easily write as 1 gram per ml, right? 1 gram per ml comes out to be 10 to power 6 ppm, right? So but I want to find out in 100 ml, right? So I want to find out in 100 ml, right? So I can write here as 0.01 mole of 0.01 mole of calcium carbonate, right? So 0.01 mole of calcium carbonate is equals to, or you can say that contains in 100 ml, right? So 0.01 mole of calcium carbonate in 100 ml of water is in 100 ml of water is, so it becomes you can say this divided by 100, that's it, right? So it comes out to be 10 to power 6 divided by 100 ppm, right? So divided by 100 ppm, right? So it comes out to be 10,000 ppm, right? Or you can say that 10 to power 4, right? So 10 to power 4, right? So here, but in the question we have asked that what is the value of x, right? So it is given, it is equals to 10 to power x, right? So we can say that the value of x comes out to be 4, right? The value of x comes out to be 4, but in the option, right? But in the option the value of x is not given, right? So we have given the actual value, right? So it is equals to 5000 ppm, 1000 ppm, 100 ppm, or 10,000 ppm, right? So our correct answer will be 10,000 ppm, right? So our D answer will be the correct answer, right? So hope this answered your question. So thank you.